Hello friends, in this very class we're going to be looking at the third worked example on application of modular arithmetic. In our previous lessons, we looked at the first two major worked examples, and in today's class we're going to be looking at another type of example. So let's look at what we have right here on the board. The needle of a compass points east. Where will it point if it turns 2,500 degrees clockwise and anti-clockwise? So how do we solve this? Now, this is very simple. This is different from the clock. We're not talking about a clock. We're talking about a compass. Don't forget that for a clock, the standard modulo being used is the 12 hours. That's modulo 12. Don't forget that for a clock. Why? For days, weeks, months, years, and so on and so forth. The standard modulo is 7 days, modulo 7. So let's look at what is going to be the standard modulo for a compass. Now, for a compass, let's say right here, we have the north, we have the south, north-south, and then we have where's the east. So right here, let's say the blade of the blade of this very compass is right on north. So if it's on north, if it moves from here, don't forget that this is 90 degrees, first quadrant, second quadrant, third, and the fourth quadrant. So if it moves from north to east, that's 90 degrees covered. So from east to south, it's another 90 degrees, which is 180 degrees. From south to west, another 90 degrees, which is 270 degrees. From west back to the north is another 90 degrees, which is 360 degrees. So what do you observe? What lets us return to our initial position when it comes to a compass is 360 degrees movement. So when you move 360 degrees, you're going to come back to your starting position. So what do we have? Here we have 360 degrees modulo. So our mode of operation is 360 degrees. That's the standard mode of operation. So if this very this very compass, bigger pattern, is right on east, the blade is on the east, that's on the east pole, and it moves clockwise, 2,500 degrees. This clockwise motion. Clockwise simply is a natural way the hand of the clock moves, like this clockwise motion. While anti-clockwise means the unnatural way. So when the clock moves like this in an opposite direction to its natural direction, we call it anti-clockwise. So if it moves 2,500 degrees clockwise, that means it's moving like this plus 2,500 degrees. So let's quickly do that. Plus 2,500 divided by 360 degrees. We're going to create a 360 times table. We're going to get the multiples of this. So 360 times 0 is 0. 360 times 1 will give us 360 times 2, 720 degrees. We're going to continue like that. Let's try it up to, let's try times 6. 360 times 6 will give us, 6 times 6 is 216, 216 degrees. So 360 times 7, we're looking for 2,500. 360 times 7 will give us 2520. This is way more than what we're looking for. So that's more than this. So we're going to stop. We're going to go with this. So 360 into 2,500 will give us, that'll give us 6, which is 2160. 2,500 minus 2160 will give us 6 remainder 340. So what do we have? We have 340 degrees modulo 360 degrees. That's what we have right here. So it means this very blade of this compass that's right here on east, that's on the east pole, we move forward 2,500 degrees. That's going to complete 6 revolutions. So 360, 360, 6 places. So on the sixth, movement, the sixth revolution, we're going to get back to the east. But that's not all. We have plus 340 degrees remainder. So what do we have? We're going to move from this east and add 340 degrees to it. Don't forget this plus 340 degrees. Remainder is always positive. So we're going to move east to south. That is 90 degrees. Another one, 180, down to the west. Down to the north, 270 degrees. Now from the north back to the east, that will be 360 degrees. But we're talking about 340. So at the north is 270. 90, 180, 270. So we're going to add 70 degrees to it, which will take us to northeast. So for the clockwise motion, what do we have? The result is going to be north, 70 degrees east. That's the result for the clockwise movement. So that's that, as simple as that. So 2,500 degrees revolution or turning clockwise, that's in the clockwise direction, our result will end up being what? around us, the blade will stop between the north and the east, 70 degrees, so north, 70 degrees east. So let's look at the anti-clockwise movement. If it moves from here, like this, anti-clockwise, 2,500 degrees, that's going to be minus 2,500 divided by 360 degrees. Now, don't forget something. In our previous lesson, we already worked on how we could easily work on negative result. I could create a table down looking for the result that will match this in the negative direction, but I can save myself the stress. How do I do that? I will work on the positive stuff first. We've already done that up there. 2,500 degrees divided by 360 degrees. What will it give us in modulo 360? That will give us plus 340 degrees in modulo 360 degrees. Now, if the positive 2,500 degrees gives us plus 340, then the negative 2,500 degrees will give us what? What are we going to get? Don't forget, you're just going to subtract. We take this remainder off the modulo of operation. So that will be 360 minus 340. That will give us plus 20 degrees modulo 360 degrees. So we have plus 20 degrees modulo 360 degrees. So it means after moving in this opposite direction, a couple of times, probably about, maybe 9 times or thereabout, maybe about six to 7 times, then we get back to work to this very spot. We get back to the east. So at the end of the day, we have to add 20 degrees to it. So from the east, you're going to move this plus 20. Don't forget that, not minus. The remainder is always positive. So we're going to move from here plus 20. So we're going to have this 20 degrees. So we have 70 degrees. So the result is south 70 degrees east. That is the anti-clockwise motion. So as it moves, we end up having, it's going to stop at south 70 degrees east for the 2,500 degrees turning. As simple as that. As you can see, it's very, very easy. This anti-clockwise rotation or movement. So that's that for this. It's very, very simple. As you can see, modular arithmetic is very, very interesting when it comes to its application. Very, very interesting. So we've come to the end of this very lesson. If you've gained 1 or 2 things from this very lesson, I would love you to give me a follow on Facebook and Revelation Hub and subscribe to the very channel at EduMosaic on YouTube. And please don't forget, share this lesson also with others. See you in the next lesson. Thanks and bye for now.